Steel sheets become strength itself at Arslan Damper, where each cut, bend, and weld defines the anatomy of a working dumper. Operating today on a 25,000 square meter site, the company blends large-scale engineering with strict quality control. The factory's organized layout shows how every stage, from steel cutting to final assembly, flows like an unbroken system of discipline. Assembly and structural fabrication start with certified ST52, ST44, and ST37 steel plates supplied from trusted European mills. These are cut on computer-aided CNC machines, ensuring accurate geometry for the chassis and load-bearing frames. Each component is then shaped through 8-meter bending presses using wear-resistant Hardox plates with up to 450 Brinell hardness. Seeing those thick plates curve into perfect alignment feels like watching raw power obeying geometry. The preparation and installation teams synchronize their work, one forming the subframes, the other aligning and joining assemblies for hydraulic integration. Hydraulic control valves, pumps, and limit systems are mounted next, setting the backbone for dumper functionality. You can sense the confidence in the crew when each hydraulic joint fits without a single correction. NNN. The quality control phase takes over before painting, with pressure and function tests verifying that dumpers can operate safely under extreme excavation conditions. After approval, each vehicle is treated with chemical washing and sandblasting. Then, the painting plant applies 2 coats of epoxy primer and 2 layers of acrylic elastic paint in heated booths to guarantee long-lasting protection. No wonder those finished dumpers look like they could handle a decade of storms. The Arslan Damper team continues to develop new models based on customer feedback and field research, reinforcing its reputation as a market leader in robust and ergonomic truck equipment. That constant loop of design, feedback, and refinement keeps their production line alive like a heartbeat of engineering. Final assembly involves fitting standard accessories and branding elements, followed by a last inspection for structural alignment and finish quality. Every dumper is then field tested under load in real excavation conditions, right before shipment to domestic and international clients. It's the moment where design and endurance shake hands. The Arslan Damper team continues to develop new models based on customer feedback and field research, reinforcing its reputation as a market leader in robust and ergonomic truck equipment. That constant loop of design, feedback, and refinement keeps their production line alive like a heartbeat of engineering.
Dozens of workstations, layers of quality checks, and one result: a complete container module made by KLEUSBERG in Germany. Built entirely in Germany, these containers are engineered for decades of reliable use in schools, offices, and construction sites. Steel preparation sets the foundation. Sheets are cut, aligned, and welded to meet DIN EN 1090-2 standards. From there, the container frame takes shape under tight supervision. No shortcuts here. Each weld is tested before moving on. After priming, production planning ensures every unit follows the same high-quality path. Next come electrical and piping layouts, followed by ceiling and floor assembly. Windows and wall elements are fitted with exact alignment in the company's own element production line. The roof is added, and the unit heads for painting, where its final color coating seals both protection and appearance. That glossy finish always looks like it's ready for the road. Once electrical and sanitary installations are in, the container faces a full functional inspection. Surviving those checks is like passing boot camp for steel boxes. Finally, each approved module is shipped through a precise logistics chain to its destination, a process that ensures every KLEUSBERG container leaves the factory as a fully functional, self-contained space. Nen.
The process begins with uncoiling a steel strip, which is leveled and edge trimmed to ensure uniformity. The strip is then fed into a spiral forming system, where it is shaped into a continuous helical pipe using advanced forming technology. The pipe is welded using either submerged arc welding. Both inner and outer seams are welded simultaneously for structural integrity. Dual seam tracking ensures accurate alignment of the longitudinal edges of the strip, critical for achieving strong and consistent welds. This system employs real-time sensors and advanced control software to monitor and adjust the welding process, minimizing defects. After welding, the pipe undergoes ultrasonic and X-ray inspections to detect any defects. It is then cut to the desired length, hydrostatically tested, and beveled for joining. The MAV, 3-roll variable axis, plate roll is a heavy-duty machine engineered for precision and power, ideal for rolling thick plates for pressure vessels. At North Shore Steel, this advanced machine effortlessly shapes 5.25-inch, 130 mm ASME plates with exceptional speed and accuracy. The plate roll features a robust 3-roll design with variable axis movement, allowing unparalleled flexibility in handling different plate thicknesses and diameters. The top roll presses the plate into a predefined curve, while the adjustable lower rolls provide controlled support and pressure to achieve precise results. This design minimizes material springback, ensuring uniform rolling with minimal corrections. Designed for demanding applications, such as pressure vessels, it delivers consistent performance under high loads. The tandem press brake for street pole manufacturing, equipped with DA52 control, automates the bending process to produce large, uniform poles. Its automatic front feeding system efficiently positions the sheet metal for precise operations, reducing manual handling and increasing throughput. The Y1 and Y2 control axes operate independently, allowing accurate synchronization of both press brakes in the tandem setup. This ensures smooth and consistent bending over long lengths, critical for street pole fabrication. The machine's synchronized hydraulic system, coupled with its advanced control and feeding mechanisms, guarantees minimal deviations, superior repeatability, and excellent quality of the final product. The production of longitudinal submerged arc welded (LSAW) pipes begins with cool bending, where the steel plate is formed into a cylindrical shape without the application of heat. Once shaped, the pipe undergoes external submerged arc welding, SAW, where the seam is welded along the exterior to create a robust and defect-free joint. The same process is performed internally through internal SAW, ensuring full joint penetration and further strengthening the pipe. After welding, the pipe is subjected to an internal visual inspection to verify the quality of the internal weld and identify any visible defects. This automatic metal sheet cone shape bending machine is a specialized piece of equipment designed to form flat metal sheets into conical shapes with precision and efficiency. The process begins with material loading, where a flat metal sheet is placed onto the machine. This can be done manually or through an automated feeding system. Once in place, the sheet is aligned accurately to ensure consistent results. The next step is sheet clamping. Hydraulic or mechanical clamps firmly secure the metal sheet to prevent any movement during the bending process. This ensures that the final product is dimensionally accurate and free of defects. Proper clamping is critical, especially when working with thicker or high-strength materials. The bending process itself is achieved through roll bending. The machine typically employs a set of 3 rollers configured in a pyramid shape. One roller remains stationary, while the others are adjustable to control the bending angle and radius. By incrementally adjusting the roller positions, the machine gradually bends the sheet into a cone shape. Advanced machines often feature CNC controls, allowing for precise adjustments and automation of the bending sequence. Bending machines play a pivotal role in modern manufacturing, enabling precise and efficient forming of metal profiles, pipes, and sheets into desired shapes. These machines are integral to industries such as construction, shipbuilding, aerospace, automotive, and energy production. With advancements in automation and computer numerical control (CNC) technology, bending machines now deliver unparalleled accuracy, repeatability, and productivity. Below, we delve into the specific roles and capabilities of various bending machine types and their applications. Bending rolls machines. Bending rolls machines are essential for forming cylindrical and conical shapes in metal sheets, widely used in industries like shipbuilding and pressure vessel manufacturing. These machines typically feature 3 or 4 rolls, with CNC models achieving remarkable precision. For instance, CNC bending rolls machines handle sheet thicknesses ranging from 1 mm to 200 mm and widths up to 6 meters. Special bending rolls equipment ensures consistent production of large diameter pipes, such as those required for wind towers or offshore platforms. Section benders and CNC profile bending machines. Section benders, also known as profile bending machines, are used for bending structural profiles such as I-beams, U-channels, and T-sections. These machines are crucial in creating custom metal components for architectural, industrial, and transportation purposes. CNC profile bending machines enhance precision and flexibility, handling tasks like bending profiles with a radius as tight as 1.5 times the profile width, accommodating sections with dimensions up to 400 mm by 200 mm in a single pass. Specialized applications. Forming and bending spirals. Machines like spiral benders are tailored for applications such as heat exchangers and industrial springs. These machines achieve diameters ranging from 50 mm to 5 meters. Forming and bending coils. Used in energy industries, such as coil production for transformers, bending machines ensure consistent and precise shaping. Universal roller benders. Centrius's Universales a Galette. These machines offer flexibility for bending diverse profiles, making them indispensable in custom fabrication. Pipe and tube bending. Bending machines for pipes and tubes serve applications in HVAC systems, automotive exhaust systems, and oil and gas pipelines. CNC pipe and tube bending machines provide precision angles as tight as 0.1 degrees, ensuring minimal material wastage. Capability to handle pipes with diameters up to 500 mm and wall thicknesses up to 20 mm.
A manual machine crafted for elbow bending from pipe E120 goes to work shaping each segment with precision. The pipe is first secured, then bent at the designated angle while maintaining wall integrity. The way the operator positions the pipe and triggers the bend is unexpectedly smooth, like the machine knows the angle before the bend even happens. Once the bend is formed, the machine checks the radius and straightness, ensuring each elbow meets spec. Seeing a straight pipe turn into a perfect elbow feels like a sculptor's touch in an industrial setting. The finished elbow is then trimmed, deburred, and ready for installation in ventilation or fluid systems. It's surprising how a seemingly simple bend can demand such consistency and control. N. Watch the coil feed. Roller stations and flying shear work seamlessly on the Gungor Machina Trapez roll form line. The coil is fed automatically into the decoiler, straightener, and leveler modules to ensure flatness before entering the forming section. Every coil unwinds under precise tension control to prevent edge distortion. E. The pace of sheet material moving through this line demands synchronization between feeder, rollers, and cutters that is almost uncanny. Each roller pair engages the sheet with measured pressure, ensuring a perfect start to the forming sequence. The forming section uses a series of shaping stations where rollers progressively bend the metal into the trapezoidal profile while maintaining sheet thickness and edge quality. N. Once the profile is formed, the line advances the sheet to the flying shear, which cuts at full speed without stopping the line. The flying shear times each stroke using sensors that track the sheet's motion in milliseconds. Cuts are clean and fast, like the line's heartbeat skipping only for a moment. After cutting, the stacker receives the sheets, aligning and stacking them ready for loading or further processing. Each finished sheet slides smoothly into place, forming a perfectly leveled pile. The automation reduces manual handling, while sensors monitor speed, thickness, and profile accuracy in real time. NNN. Seeing the stacker align each sheet one after the other shows how tightly controlled the flow really is. Maintenance teams often rely on live diagnostics from this system to keep production continuous. The entire system combines robust mechanics, high speed, and precise regulation to deliver efficient roll-forming production for trapezoidal metal profiles.
Every rotation of the coil and stroke of the die in the SA315S3.3 press line is part of a choreography of steel in motion that defines Schuler's high-speed forming. This high-speed press is the core of a fully automated system built for continuous production of electrical laminations. Every hit of the press delivers consistency that defines industrial reliability. Work begins as steel coils are loaded onto the dual decoiler. Each coil unwinds smoothly while maintaining perfect tension through the looping pit system. A traversing non-contact thickness gauge monitors the strip to ensure the material stays within tolerance. That constant scan is what keeps the press honest. No deviation slips past. The strip moves forward into the die area, guided by precision feed rollers. The SA315S3.3 performs high-frequency stamping of laminations that later form the cores of motors and generators. Its control unit synchronizes feed speed, press stroke, and die operation to maintain repeatable output even under long production runs. The pace is relentless, but everything moves in harmony. Once laminated stacks are punched, rotor and stator packets are automatically separated and picked up by robotic handling arms. Each packet is stacked, aligned, and checked for dimensional accuracy before being placed in the output station. Automation here doesn't just save time, it removes the slightest risk of misalignment that could cause vibration in a finished motor. The system also includes motorized slide-out tables and segmented clamping plates, simplifying die changes and maintenance. The integration of all components into the central press control allows operators to oversee the entire cycle from one interface. That's efficiency wrapped in steel and code.n. When the press runs at full speed, producing stacks at a blur, you can't help but feel a spark of excitement, not from electricity, but from seeing engineering turn raw metal into something that powers the world.
Under the TrueLaser Cell 3000, beams of pure light trace flawless contours across steel. This 5-axis system handles both 2D and 3D parts, switching effortlessly between cutting and welding. It feels almost unreal how precise and consistent the paths stay at high speed. The setup allows full flexibility, from prototypes to large production runs, without needing tool changes. For a gusset bracket, the laser head moves in synchronized arcs, melting through metal with micron-level accuracy. One wrong setup here, and the cut would drift off instantly. Yet it never does. Parts emerge with smooth edges, no rework required. Adjustments happen automatically as the sensors track every curve and depth. Un-N-N. The True Laser Cell 3000 proves how adaptable laser manufacturing has become, capable of sculpting complex geometries on command. Makes you think how far light itself has come as a tool for shaping metal NN.
Behind each Tadano crane lies tons of steel, thousands of welds, and a power system that turns hydraulic pressure into control. Production begins long before the machine lifts its first load. Deep inside the plant, where every cylinder, frame, and boom takes shape through relentless mechanical work. The scale of coordination here feels almost like an orchestra of steel and hydraulics. Hydraulic cylinder manufacturing comes first, followed by plating to protect the inner surfaces from corrosion. Then, the massive boom sections are welded and given anti-rust coating. Hydraulic piping is assembled next, connecting the entire pressure system that powers the lifting functions. The turntable structure is fabricated. Then the winch drum is installed to control cable movement. Every bolt on that drum means trust when tons of weight hang below. Cab and carrier frame production proceed in parallel, each designed for durability and operator comfort. Automated storage systems and AGVs deliver parts, streamlining assembly. Axles, engine, and tires are mounted before the turntable, boom, and wire rope come together. Final inspection and painting seal the process. That last coat always brings a quiet sense of completion. Tadano's cranes emerge not just as machines, but as extensions of human capability. Hard not to picture this crane lifting something far beyond its own size someday. Few imagine that behind every EUROWATER system lies a vessel born from molten sparks and exact alignment at a Danish workshop. Each stage here turns raw, rolled steel into a structure built to endure extreme operating conditions. The rhythm of welding sparks and moving cranes sets a tone of power rather than noise. Flat steel plates arrive first, cut precisely to match each vessel's design specifications. The edges are prepared for joining, ensuring no flaws in later welding. Next, these plates are rolled into cylindrical shells on massive bending machines, giving the vessel its robust foundation. The scale of each roll feels almost alive when steel starts curving under sheer mechanical force. Sections are then aligned and welded together, forming the main body with seams strong enough to handle high internal pressure. Internal components such as nozzles, inlets, and reinforcing rings are mounted. Skilled welders handle these fittings with steady accuracy, keeping alignment exact to prevent leakage under operation. One tiny deviation here could change how the vessel performs under test pressure. After the head ends are attached, the vessel takes its final shape, ready for surface finishing. The entire structure undergoes grinding and shot blasting to remove impurities and roughness, leaving a clean, uniform exterior. Protective coatings are applied to resist corrosion, ensuring the vessel's durability through years of water treatment service. There's a quiet satisfaction in seeing dull steel turn into a glossy, sealed product. Finally, each vessel is pressure tested under controlled conditions to verify its strength and safety before shipment. EUROWATER's vessels embody reliability, made to keep water pure, and systems running efficiently. It's the kind of process that reminds you how much quiet precision stands behind clean water. Rainwater systems get a major upgrade with the Modular RBT270DLX, a fully automatic roll-forming machine built in Brazil for seamless downspout and gutter production. It works with galvanized steel sheets up to 270 millimeters wide, producing pieces from 3 to 6 meters long. Rounded corners improve water flow, while reinforced profiles add rigidity and reduce deformation. That smooth finish with no weld lines looks way too clean to leak. The RBT270DLX also bends seamless elbows, front, side, or combined through a hydraulic folding system. Corrugated style curves are made instantly, turning raw sheet into functional sections in seconds. You can tell it's a machine made for rainy season heroes. Pre-painted sheets can be used for colorful production runs, giving builders flexible design options with lasting durability. Segments hundreds of feet tall are maneuvered into alignment before final welding in Campbelltown. Each cylinder segment is guided into precise alignment before welding, ensuring structural integrity for towers that will face strong coastal winds. End sections move along automated rollers toward welding stations, where skilled operators secure them with strong joints. Throughout production, quality checks ensure each weld, bolt, and plate meets the high standards required for renewable energy structures. The combination of heavy-duty machinery, precise human oversight, and systematic handling allows Scotland's only wind tower facility to keep turbines turning reliably. The engineers, skill, and the machines, power together, make these coastal giants possible. After assembly, internal ladders and platforms are installed, allowing future maintenance crews to safely navigate the interior. The scale is jaw-dropping. Imagine climbing up hundreds of feet inside these hollow cylinders.
Pre-cut lengths, pre-punched holes, and a 1-hour fire rating. Total Joist turns those specs into real construction speed. Each joist arrives pre-cut and labeled, moisture-resistant, and ready to assemble on site. Delivery and handling come first. Bundles of 8 to 15 joists are stored upright, keeping them clean and dry until installation. Layout follows next, marking the steel track positions along the interior walls for balloon framing. Seeing the crew align everything this smoothly really shows how practical pre-engineered steel can be. Assembly begins as the end connectors, either full height or regular, are attached to the joists. The adjustable design allows for quick fine-tuning, giving installers up to 3/4 of an inch of flexibility. That small adjustment range saves big time when dealing with uneven site conditions. Joists can even be doubled or tripled to form beams, joined with Z-connectors spaced evenly for load strength N and N. With connectors in place, each joist is lifted, positioned, and screwed securely to the track. Proper torque settings ensure tight steel-to-steel joints without deformation. The way each joist locks into place looks almost like a well-practiced move on a construction site. Blocking and bridging then stabilize the frame every 8 feet, using solid steel angles to tie the perimeter and prep for decking N. Floor sheathing completes the line. Plywood, OSB, cement-bonded board, or steel decking like the one shown here. The self-drilling screws and stand-up decking tools make fastening efficient and ergonomic. Once done, the floor becomes a strong, level base ready for topping. You wouldn't expect lightweight steel to feel this solid once everything's in. The result is a durable, fire-rated, and space-saving system that defines modern light steel building efficiency.